Yes, sir. Okay, so I'm going to go over the quiz number 4 from last week on the 20, let me see, that was taken on October 25th. Okay, let me go ahead and share screen. Okay, so you can see most of my already have the answer here on the sheet. Now you already have answer on your sheet, just compare it to yours. So for number 1 is the answer is D as in David. Number 2 is the answer is C as in David. And number 3 is the answer is B as in Bob. Okay. So this one, so the voltage at the base of the NPN transistor operate in the active region. The active region, you have to get the diode to go beyond 0.6 volt or more to make it forward bias. So that's why it's 0.6. So the answer was D on number 1. Number 2, the base emitter voltage fall below 0.6 volt. The transistor will approach a mainly cutoff. It's mainly off from this here. Okay. So when you're so when this one right here, so the base from the base to the emitter here, once once there's no when it's reverse bias, when it's not forward bias anymore, it would be operating. It should be operating right here at the cutoff. Whatever the voltage here would flow directly to the go through emitter. Okay. So that's why it's the cutoff, and there won't be any there won't be current at all at IC. Okay. So and then in the cutoff region, a transistor is turned off, essentially no current flowing. So the answer is B on number 3. Okay. So any question on number 1, 2, or 3? Okay, no question. All right, next set. Okay, so in order for a transistor to properly amplify AC signal, it must operate in the active region at all times. So the answer for 4 is B. Active region is right here at the Q point. Okay, at where most of the active around the Q point area, around this area. Okay, so you can be in the saturation, or you cannot be in the saturation, or you cannot be in the cutoff. You can be only in this region right here. This is your active region. Okay. Okay, number 5, in a common base transistor circuit, which terminal is common to the input and output of AC signal? Okay, so the answer is C as in cat for number 5. So this is where, so common base would be something right here. So common base, this is from the handout from the website, okay? So common base, so the input and the output, so the both of them is it's connected to the ground, which is right here, okay? So that's the common base. So so let me see, so that's common base, so common to input and output AC signals. Okay, it's at the base terminal. Okay, in the common emitter transistor circuit, the AC output signal is it's 180 degree out of phase. Okay, so the answer is C as in cat. Okay, this is what it is. You have input, that's the signal like this here. So you have on the and when you get the positive signal goes here, and then your output will be going toward a negative peak, okay? And when this is go to the negative peak on the input, it inverted to the positive side on the signal on the output, okay? So that's why it's 180 degree out of phase. So the answer is 6 is C. So any question number 4, 5, or 6?
I'm sorry, I just logged on. Did you have 2 number 6s?
Yeah, 2 number 6. I will go over both of them. So whichever one it is that you put, I will accept as the answer. Okay.
As long as it's right, correct?
As long as it's right, correct. If it's wrong, then you lost. Okay, so that's number 4, 5, and 6. Okay, next set. Okay, this is also number 6. This is based on the calculation. So if you did this, then you got it. So number 6 is said to calculate the voltage at C. And so point C is right here. So point C is going to be, so if you put your meter, your DMM, your high side would be at point C, and the low side would be at the common, would be over here. So same thing as measuring over your diode, which is about 0.7 volts. So the answer is B as in Bob for number 6. Okay, for number 7, for the circuit shown, the current through 1K resistor would be right here between A and B. Okay, so the answer is A, 11.72 milliamps. So first thing you want to do is first you have to do is just figure out the voltage drop over this 1K first. Okay, and that's what I was able to use by using the voltage divider. Okay, that's apply the voltage divider, do that calculation. It give you 11.72 a volt, and then you use that to calculate the current. And that's come to 11.72 milliamps. So the answer is A as in apple for number 7. Now for number 8, for the circuit shown, the voltage across 1.5 kilo ohm is, okay, so the answer is would be C, 17.58 volt for number 8. Okay, so therefore, so that the 1.5 volt would be right here. So we know that the voltage that is applying to here, it's going to be just the 30 volt minus the voltage drop over this one, and that would give you the value at point B, okay? And then point B minus the voltage, and then minus the voltage over point C, that will give you the voltage drop over the 1.5, okay? So that's why 30 minus the 11.72 minus the 0.7 volt of the diode, so yield about 17.58 volt as your output. So the answer is C for number 8. Okay, any question number 6, 7, or 8?
Oh, San,
Yes.
what about the question number 6? Is it going to be B or C? Because there are 2.
Like I said, I graded. So if you have any one of the answer, either B or C, it would be, I would give you the credit for it.
Okay, thank you.
Okay, so anything else, number 6, 7, or 8? All right, next one. Okay, for the circuit shown, the voltage across the 490 ohms, 490 ohm resistor is, so 490 ohms over the load resistor. Okay, so for load resistor, we're going to use, so when you're doing this calculation, first thing you want to do is just ignore this one first to calculate just what the voltage would be at the output. Okay, so that would represent the voltage divider. So VL equals VN times RL divided by the quantity R plus RL. Okay, and that's you calculate its yield 12.25 volt. Okay, so that's over the amount of the Zener diode. So the Zener diode is going to eliminate whatever is more than the Zener diode. The Zener diode goes into breakdown. And so the yield that's going to go out is mainly just the 12 volt. It cannot go up to 12.25, okay? So the answer for number 9 is A, 12 volt. Represented Zener diode, this one right here. Okay, and then once we have that information, now we can use to calculate the current. Okay, so with the current, so I total equal to VN minus VL divided by R. Okay, so we know that VL in this case is going to be just a 12 volt that will be dropping, because this one is, like I said, we only get 12 volt possible that will go out. So 24 minus 12 divided by 470 ohms, that's give you about 0.02554 3 amps, and then they converted to milliamps, so 25.5 milliamps. So the answer is B as in Bob for number 10. Now number 11, for the circuit shown, the current through the Zener diode is the same thing as the current that will be traveling through R as well as through here. Okay, so That's just the so the I total. Well, it's going to get split. Some will go down this way, and some go down over the load resistor. Okay, so you want an I total minus the I load. That will leave you with the IZ. Okay, so that's what we have here. And then once you do that calculation, it comes up to 1.04 milliamps. Okay, so you can round it up to, so the answer is B for number 11. Okay, so any question number 9, 10, or 11? Everyone clear? All right, next set. Okay, so next set, okay, question number 12 for the circuit showing the voltage at VB. So VB would be right here. And so this is represent a voltage divider, like we said before. And so it's going to take the VCC times the R2 times the divided by the quantity R1 plus R2. That's going to give you the answer is going to be 6 volt. So the answer is B as in Bob for number 12. Now for number 13, for the circuit showing the voltage VE is, so VE is going to be right here. So you're going to take the VB minus the VBE, which is represent the diode that from the base to emitter. And that would be 6 volt minus 0.7 volt. That give you a 5.3 volt. So the answer is C as in cat for number 13. Okay. Number 14 for the circuit showing the current IE is, so the current through IE. So now that we have VE, we have to do just take the VE divided by RE. That's give us about 3.53 milliamps. So the answer for number 14 is A as in apple for number 14. Okay, any question number 12, 13, or 14? Okay, no question, next. Okay, so number 15 for the circuit showing the current IB is, so we're going to use IB. So we know that IE from the previous was 3.53 milliamps. So IB would be IE divided by the quantity 1 plus beta. And that would be 3.53 milliamps divided by the quantity 1 plus 200. And that yields 0.01757 milliamps. So the answer, so you can drop off this last two set, just the 17 milliamps, it would be fine. So the answer is C as in cat for number 15. Okay, for number 16, for the circuit showing the current IC is, IC should be going to be approximately equal to your IE. So therefore, approximately, and then if you can do the calculation, same thing, you can take the beta times IB. So we got the IB would be here, multiply again to beta. In this case, the beta is 200 right here in your circuit. And that give you a 3.51 milliamps. So that's close enough to your IE here. And so the answer is, so this one is, so if you use the rounded up number, it would come to the 0.17, it comes up to about 3.48 milliamps, okay? But I keep all the unit, so mine's a little bit more, but the answer is A as an apple for 16. Okay, number 17 for the circuit showing the voltage VC is, so VC, we go through the whole process. So VC equal to VCC minus the voltage drop over RC here. And that would give, so 15 minus the 3.51 milliamps times 2.2 kilo ohms, that comes yield 7.26 volt. I'll round it up, 7.3 volt. So the answer is B as in Bob for number 17. So any question, 15, 16, or 17?
No.
Okay, good. All right, next set. Okay, this one's the last set. Okay, for the circuit shown, the voltage VE. Okay, so VE would be here. So there's going to be the voltage that's going to be VB. So first we want to do is calculate the VBB first. Okay, so VBB is going to like we said, it's going to be the voltage divider. That's do the calculation. It should be coming 6.87 volt. And then you use that, and then VE would be VBB plus VBE, okay? Previously we subtract VBE. In this case, because it's a PNP, we're going to add VBE. Okay, so that's 6.87 volt plus 0.7 volt. That give you as a 7.57 volt. So the answer is B as in Bob for number 18. Okay, for 19, for the circuit shown, the current IE is, so IE, since we have VE, the same thing. So they're going to be the VEE minus VE. So that's going to be the voltage drop. And then so we can calculate the current that's going through the to RE. Okay, so therefore it comes up to about 2.42 milliamps, so going through here. Okay, so the answer 19 is C, as in cat. For number 20, for the circuit shown, the voltage VC is approximately going to be about 5.30 volt. Like I said, it's going to be approximately, the current going to be approximately equal to the IE, but you can definitely do your calculations. It's going to take the IB times the beta. In this case, beta is 150. So that's what we did here. And then we did calculation. So that's give us a 2.04 milliamps. And then we use that current to multiply against the RE. That's give us the voltage at VC, okay, which is come to 5.3 volt. So the answer is A as in apple for number 20. Okay, so any question number 18, 19, or 20?
Nope.
Okay, no question. Let me look at the chat real quick. Okay, look like everything is good. Okay, back to you, Mr. Pham. Thank you.
May I see number 9 again, please?
Okay, all right, number 9. Number 9. Okay, number 9 is here. Okay. Yeah, first thing you want to do is calculate without the Zener diode first, okay? So by applying the voltage divider, and it will yield about 12.25. And at this point, the Zener diode will go into breakdown, and so therefore whatever it is that is more than whatever the Zener diode is, the Zener diode only give out only 12 volt output. And so therefore they're going to ignore this. They're going to put out only the 12 volt out. Okay.
Thank you.
You're welcome. Okay. Back to you, Mr. Pham. Thank you.
Thank you, Sam.
Okay.
Okay, so you know, on this semester, we don't have a much time. Okay, this is in November. You get only 3 weeks. Then you get a holiday for Thanksgiving, 1 week. And on December, you get only 2 weeks. Then you get a holiday for Christmas. Then the last January, I think you get about 3. So that is really, you get about 2 more months to complete this fall 2021. To me, for the lecture, I believe will be okay. We can handle it. However, the big problem is the lab. All of the students start from spring 2020 up until today. We don't have a time to do in the hand-on training. That means you're really working on the lab. On the next semester, you will be also get the digital and also including digital lab. So if you cannot done for the electronic lab in the lab vault. The next semester, you have to do 2 labs. One will be still working on the lab vault. And also you have to do on the digital lab in order to get the certificate in the spring 2022. I get a lot of still more students get a problem. Thing that you cannot get into the lab at this time. And maybe, and I think they still continuing the same way in the spring 2022. That means whatever we done, we running the program in the fall 2021. They will be happen again on spring 2022. That will be take a long time for the student cannot get into the class to do the electronic lab. I don't want that. However, that's out of my control. Everything now, depending on the continuing education. Okay. So what I try to do is I try to help your guy understand how to do electronic lab at this semester. If you already know how to do it, you can speed it up, get it done as much as you can. Okay. I know how to do the left vault, but I never did it. But that's not a problem. Okay. So if you get any question or anything confusing, I will really help you out. Okay. So before now today, I will be start with the left vault. I want to try to see, okay, how long will take for me to do it. And also try to see how many things you want to ask it. Anything else you want to know. Normally, this week we do AC. Next week we'll be doing on the semiconductor. That's your circuit board. Right now, we'll be doing it. Okay? If you get done for AC1, AC2, you can doing electronic semiconductor. Okay? And after you get a semiconductor done, you can working on bipolar transistor amplifier and keep going. Okay, any question, anything?
Yeah, I have a question.
Yeah, go ahead.
Is that possible to have more hour than we have schedule? For example, 1 hour more or something like that to try to complete the lab?
Okay, that means you want to get a little more time, right?
Yeah, 1 hour more every section, you know, because 2 hours is not enough.
What do you mean, not enough? Right now, for my understand, if we still get the empty left vault during lab time, when the people figure it out full on each days, then I can think about that. But right now, on Wednesday, we still get few labs still open. Same thing for the other days. So what can I do?
For example, arrive early 3 o'clock until 7, or 4 o'clock until 7.
Normally, you get 3 or 5.
I arrive at 5 because of work.
Okay, you come in 5, you do it 5.
Okay.
If you get a time, you can go at 3. We get a available lab, you can do it.
Okay.
Okay. Only thing is, on each day, we get food on 16 left phone station. Then I have to thinking about how can I increase for more students, but not at this time. So you leaving, get to complete the program soon or later, depending on yourself, for everyone. I hope someday they go back normal, like before the COVID-19. That means under my control. That will be help a lot, but I don't know. What I cannot do anything at this time. Keep running. Okay, any more question or anything else?
Hey, Professor, are we eventually going to go to labs 4 days a week and lecture 1 day a week? I remember you talked about that last time.
Now, the thing is right now, what the problem is, see, they limit the hour of the instructor. Okay, so that's why.
Okay, thank you.
Yeah, they pay for you only 4 days, 4 hours, week 12 hour for 4 hours a day and 12 hours a week. So they working only 3 days. They cannot working more than 12 hours a week. I want to get more, but I cannot do anything. On an instructor, just a part-time job. Okay, anything else? Okay, just wait for me, okay? Okay, so today I will go with the AC1. Okay. And basically, I just go to the lab. I'm not going to the lecture. Okay. Let's see which one is it here. Okay, so you can see a display on the lab. First thing they say you need to clear AC fundamental circuit board and connect the circuit show. Okay, this one I'm not trying to do anything, but I want to emphasize on the few things. They will be telling you they want to build this circuit. Okay, I'm not so on the circuit board now. Then, this is what I want to say. They want to turn on generator, set frequency, 60 Hz, and oscilloscope, switch the channel 1 vertical coupling AC or whatever. Okay, now, on this instruction here, you cannot apply into what we're doing for now. This is the level that was long time ago. They're using analog scope. So that's why they have to set up something. However, to this program, we're using different oscilloscope. So you cannot, better not following the instruction here. Only thing, you want to know what signal they want to be applied. They want 6 volt peak to peak and 60 Hz frequency. Okay, so only thing what you need, and you have to verify you get 6 volt peak to peak at 60 Hz. That'd be fine. Okay, so again, on the setup for the oscilloscope, we ignore, okay, in the level. We just want what they want, and you do it, okay? And now we can go into the circuitry we'll be working on for today. And I will be showing you everything. Okay, Now, they said locate inductive reactant circuit. That means this circuitry. And you connect the circuitry the way they want it. Okay, let me show you on the circuit. Can you see the circuit?
Yes.
Okay. This is the circuitry they want you to build. Inductive, okay. Reactant. So first thing what you have to do is connect the circuitry. Exactly they show you on the display. So you can see right here. This is a broken line. Okay. So in order to do it, you must be using the 2-pole. Okay. This is the 2-pole. Connect the wire. So I connect this one. So connect the output generator to the circuit. What else I need to connect?
The bypass of resistor.
We
Down.
need to connect,
2.
okay, from the right side R1 to L1. C1, right? So this means you have to connect another one here. Okay, and one more, they will be connect here. That correct?
Yep.
Okay. That's what we make a connection. And now they say active generator 10 volt, peak to peak, and a frequency 1 kilohertz. Okay. So first thing I connect the generator output to the circuitry. Okay, so basically this generator, okay, output here, I connect into output generator. Then also, I have to connect the generator route into the route. So they will be into the route. Then I connect the oscilloscope channel 1. Okay. Channel 1 into generator. Okay, this is generator here. I connect the scope channel 1. Okay, and a scope route will be connected to the route. So that are not the connection we need for now. Okay. And you want that to be 10 volt, 1 kilohertz. Okay. Now I go into the oscilloscope. Okay, so now you can see the signal on the oscilloscope.
Can you raise your camera up a little bit, Mr. Finn?
You want the camera out a little bit or in a little bit?
Thank you.
Let me want to turn on the light. Otherwise, I got a little problem.
Yeah, that looks fine. It's a little glare, but it looks fine.
Yeah, that's okay. We'll do it now. Okay, so basically you can say you get a sideway. And also on that sideway, you want okay, you want 10 volt peak to peak. So if you're looking on the oscilloscope, then you can say I in channel 1. That will be 10 volt. And the frequency will be 1.0506 kilohertz. That's only thing what you need. Whatever you're doing on your generator, we don't care. Okay? But we really care what display on the oscilloscope. If you're looking into the generator, and sometimes you can see they can get a 1.06 kilohertz. That doesn't matter to me, okay? Only thing is scope, so whatever we need to follow it. So up until this point, you get any question? Okay, if it's not, then try to see what next they want me to do. Okay, so now basically, if you're looking into here, okay, let us see. That one done. Okay, use scope to measure the peak-to-peak voltage across the RSU. That here. Okay. Can you see it?
Yes.
Yes.
Okay.
Yeah.
Now, what they want to do here, they want to measure the current, AC current, go through the circuit. But you understand you cannot using scope to measure the current. The thing is, one side of the scope must be round all the time. Okay? And that is the way LabVolt design. They want to measure the voltage across R2 10 ohm. After you get the voltage, you divide by the 10 ohm. That's how you can get the current. Okay? So now you must be connect like they show right here. Connect scope channel 1, high side here and low side here. Okay? So now I will redo it.
Adjust that orange wire to the left or right, and it'll allow your camera to focus deeper on the circuit.
That's very tough for me at this time. I have to figure out the easy way in order to get this thing done.
Just try and bend that orange wire down. Or feed that orange wire underneath the yellow wire and have that yellow wire keep it down. Whatever.
Yeah, the other thing I have to make sure I can get a clean picture for you first.
That looks nice. If you can keep, yeah, there you go.
Yeah, otherwise I still have to hold. If I have to hold it, then I cannot do. That's okay right now, right?
Yeah, that looks fine.
That's okay. Now, how can we can keep it stable?
You could duct tape the camera to your forehead.
That's a different camera. They got a different way in order to do. So that's why I still not really get along with my camera yet. So that's why. Okay, so now you can see that.
That looks nice.
Okay, take that out. Okay, and connect scope channel 1. This is scope channel 1. Now we will connect okay, connect to this side. Okay, that connect to this side. Let's see. I have to move that quick one here. That is the scope route. So the scope route will be connected into the other side. Okay, so you know how do we connect? We connect this is scope probe high side. The other side will be scope channel 1 routed. Okay, and this is very, very important. Some students, they think the route they connect into here. That's wrong. Okay, the thing is you have to get through the resistor 10 ohm. So the route on this side and the ground on the other side, they're not really good. So that's why you can get a lot of noise. Okay, if you get a good connection, then you can see the signal. And now I go back into the oscilloscope. Okay, so now you can see the signal. And now you can see the signal. And you need to press auto set measure. Okay. And they will be telling you on the channel 1, we pick to pick 182 millivolt. And the signal really very clear, no noise. So after you get that voltage, you divide into 10 ohm. Then you can enter the value for the current. However, make sure you understand, when you measure, you get around 18.2 millivolt. Then you have to converting into the voltage before you divide. Okay. So, any question on that one? You don't have any more problem, right? If you get any question, anything, just let me know. Okay, I go to the next circuitry. Okay, we already done on that one. Now, what next they want? They want to connect this circuitry. That means put the two port back to bypass 10 ohm. Okay, so I will show you. I do it. Okay, then what they want to do. Okay, now they want to connect channel 1 scope to output generator. Channel 2 oscilloscope to the right side of R1. Okay, what they want? They want to measure the voltage across R1. Okay, you understand the oscilloscope, you can only measure at a single point. You cannot measure across the resistor, voltage without any route. So basically, for example, voltage across R1, one left side will be A, right side will be B. Then the VAB equal VA minus VB. Okay? So in the analog scope, okay, they measure VA on the channel 1 and they measure VB on the channel 2. Then they have to invert channel 2. Then they add them up. That means they want VA minus VB. However, with digital scope, we don't have to do that way. We can measure channel 1, okay, and measure channel 2. Then you apply channel 1 minus channel 2. Then we can get the job done. Okay. So now I will be connect that circuitry. Let's see, scope channel 1 will be output generator. And the scope route will be routed. Okay, and the scope channel 2 okay, will be on the other side of R1. And the route of channel 2 will be connected to the route.
Hey, Mr. Pham, is that something that popped up on your screen?
Just a minute. I'm going to say what is it here. Okay, I show you on the connection. Okay, so you say this is the scope channel 1 here, channel 1. And this is the scope channel 2. Okay, so we have to measure the channel 1, measure channel 2. Okay, then using the function channel 1 minus channel 2 to get the answer. Okay, any question regarding into the connection of the circuit?
Mr. Pham, I just gotta have a real quick question.
Yeah, go ahead.
The black leads for the scope, they have to be connected to ground. Is that correct?
Don't have to be round.
Okay, so my question is on channel 2, the black lead, it's connected between R2 and L2. Is that point considered to be ground?
No, that's the same thing route. Right now you get only single route.
Okay, my question once again, I want to make sure I got this right. The point where the
Right here.
between, well, on the look, do it on the schematic because I can see it better.
Yeah, they supposed to be on the route, right?
Yeah, R2 and L2 where they come together. Is that point considered to be ground?
No, we don't get R2 anymore. We already buy card right here.
Okay, all right.
So that means all of the route have to be the same right now.
Okay, yeah, so it is grounded. Okay, thank you.
You're welcome. Okay, any more question? How to connect the circuit? Okay, if it's not, I go back to oscilloscope, try to figure out, okay, how do we measure that? Okay, I put auto set measure. So that's why you can see two signals. One in channel 1 and one in channel 2. Okay, now who tell me how do I measure? What I measure? You want to measure the voltage from left side of channel 1 minus right side of channel 1. So for this digital scope, tell me what step we have to do.
Math channel 1 minus channel 2.
Yeah, but now how can we do it?
You have to set you have to set the those voltage knobs on the scope where it says volt slash divisions. You have to put both of them on the same thing, like 1 volt, 2 volt, or whatever, but they have to be the same.
Okay, that is the first step. That means they're telling you set channel 1, channel 2 at the same voltage. Okay, right now I'm looking here, channel 1, 5 volt, channel 2, 1 volt.
Yeah, they both need to be the same.
Right, so that's why I can change, okay, either one. I can channel 2 to be 5 volt per division. You see that? If you're looking close to that, then you can see one will be 5 and another one will be 5 volt. Okay. Now, what next? Tell me how to do.
Then you want to hit math.
Okay. You hit the math. I follow you. A math button. Okay. Then what next?
Then in the upper left-hand corner near the screen, make sure it says channel 1, channel 2.
Okay.
Minus channel 2.
Now you're looking on the display. You can see one window that says channel 1 minus channel 2.
Hey, Mr. Pham, they can't see it because your mic is not showing that portion.
I believe that will be right here.
Okay, there you go.
Channel 1 minus
Channel 2.
2.
Yeah, that's better, Mr. Pham. You okay?
Okay. Then you can press the channel 1 minus channel 2, right?
Right.
And now you can see you get this signal here. Channel 1. There's a bottom here. Channel 2. And on the top here, channel 1 minus channel 2.
Channel 2. Right. Then you want to do cursor.
Yeah. Let's see. Okay, now you can see this guy will be channel 1 minus channel 2. Okay. And what else? How can we get that?
Hey, Mr. Pham, is that a 3-channel scope or 2?
2.
2? Okay.
But the thing is on the top, that's the map. That means channel 1 minus channel 2.
Okay.
Okay, how can we measure that? Let's see, if I say auto measure, see what happened. You see that? Auto measure. They
Yeah,
go
but if
right-
you do auto measure, it messes up your thing where, because one channel is 5 volts and the other one is 1 volt.
Exactly. Right now, I want to tell you, you're using the manual. So absolutely never press auto set measure.
When you're doing math.
Right. When you press auto set measure, they erase everything. Okay? And try automatic display. So now I have to do over again. I can channel 2 to 5 volt. Okay? Channel 1, 5 volt. Let me 5. Okay? Then I have to press the math button. Okay? And that will be given you channel 1 minus channel 2. And if you're moving down, on the top, will be channel 1 minus channel 2. And now we get, you see that, a little problem here. They're supposed to be stop running.
You gotta do your trigger or something?
Exactly. Let's see.
It's got a trigger button to the far right side, don't it?
Yeah. And that one right here.
Can you stop it?
What? I tried to stop it. I don't know why the fourth one.
It doesn't, the 210 doesn't have a pause or a stop? Or one pulse?
You mean for what 1 volt?
No, one pulse or pause. Screen capture.
The thing on my scope is a little different from your on the scope at the school. Even the almost working the same. I don't know why the first time they're not running. Okay, so let me try again. Okay, to see how. Okay, so I set, let's see.
Why don't you take, Mr. Pham, why don't you try to make a channel 1 a little bit smaller and make channel 2
Okay,
close to it?
that's what I'm thinking. 2 volt,
Yeah, exactly.
channel 1.
And channel 2
Now
too.
2 volt, channel 2.
Yeah, there you go.
Then I press map. Okay, then now I can move that guy down. Okay, so if I change the voltage by 5 volt and that go 5 volt, you see that? And
Yeah.
they run it. So that's why at least we can see how come they run it. You see? So I set that one to be 2 volt. And that one to be oval. Okay.
Yeah,
And-
maybe it won't work for 5.
Oh,
Sometimes-
they working with the 5 at the beginning.
Uh, I was thinking maybe it was going too fast.
Okay, so I try again. On that one, I set it to be 5. And the second one, I go to 5. Okay, and I press the map. You see that?
Mhm.
Something screw up with the scope. So you can see on the top, you get that signal. That is channel 1 minus channel 2. So this is channel 1 only. This is channel 2. And this is channel 1 minus channel 2.
Okay.
Okay? So you can measure using either cursor.
Yeah,
You
use the cursor, Mr. Pham.
you press the cursor. Okay, right now, you're looking at the cursor will be up. Okay? And you want the cursor to be time or the voltage. Okay? So now I need to turn that one to the voltage. Okay. So voltage, that is cursor on the top. And that will be cursor on the bottom. Okay. Then you reading the delta right here. 8.2 volt. So that means you can measure the voltage across the resistor.
Hey, Mr. Pham, I know you know what you're doing. In the beginning, did you make sure that the probe is like times 1 or times 10 for both of them on the scope and on the probe?
Exactly. Okay, few things. You must understand when you start with working for the generator. First thing what you need to take your oscilloscope before you do. Scope probe on both oscilloscope and the probe have to be by 1 or by 10, the same. Channel 1 and channel 2. Second thing, you must be set AC coupling. That is normally when you're working, you must set that up before you can do. Okay, so this is how you measure the voltage without ground. That means you say R1 left side, R1 right side, they not connect to the ground at all. Then you must be using channel 1 minus channel 2. Okay, any question on that one?
Mr.
The
Pham,
thing is, hold on. I want you to understand what you're doing. Okay, go ahead.
is there another option besides using the cursor where the math will display the value?
Now,
So if on the measure screen, is there an option to change the screen
I don't think so.
on type?
On this scope, if you press the measure, I don't know. I can try.
Well, I bring it up just in case the situation where a student sees an option where math can be used as a type on the screen to see a different value other than cursor.
Okay, let's see. I press the measure to see what they say. Okay, measure. Let's see. Channel 1, channel 2, channel 3. Channel 1, channel 2. Let's see. Channel. I didn't see they working. That means you have to using the cursor in order to get the pick-to-pick folder. Okay, any question on that one? I get one more to go. You'll be done.
Go ahead, Mr. Pham, go ahead.
Okay, now we go to the next one. What I have to do to understand, I have to play with my camera. That easy for me to move it from one to the other. I want to display. Okay, now we're talking about measure the phase angle. Okay. We don't care what they say here. We really care when they want you to do. Okay, so that is okay. Let's see. That is really not really good. We're done with that one. Okay, let's see. Okay, they showed you locate phase angle. That is the one right here. Okay. Now, you connect this circuit. Let's see. Channel 1 still on generator. Okay, now we go into different circuitry. Phase angle. And now you see that the phase angle. Okay. So you connect the generator and the scope. Okay. Channel 1. And now they say turn potential R2 fully clockwise. They're telling you, you have to turn that guy full counterclockwise. Okay? That's what we do it. And now, what the night? Let's see.
The only reason they have you do that, Mr.
Go ahead.
The only reason they have you do that, if I remember that part, is they wanted you supposed to line up both of the sine waves together, the in and the out. And then if they line up over each other, there's zero phase shift. When you do it counterclockwise, it moves one to the left or right, and then you have to measure your phase angle.
Exactly, that's what they want. They just want you to understand how can you measure the phase angle difference.
And you'll use a cursor to do that.
Yeah, we'll do it. Now, you have to turn at your fully, okay, clockwise. Right now, they will be still counterclockwise, okay? And they say connect using the scope probe. Set the generator sideways. 6 volt peak to peak, 1 kilohertz. So that's what I have to do. Okay, I set the generator. Will be 6 volt. Okay, and 1 kilohertz, that's fine. Then see what next. They said turn potential R2 fully clockwise. Okay, so we have to turn, okay, that one clockwise, full clockwise. Okay, and okay, connection on one probe, then connection on probe to output of the C1 across C1. So now I connect the scope probe, then on 2. Okay, output of the across the C1. Okay, so if you're looking at the scope, you get a true signal. And now, if you're moving channel 2, you're going up here. Okay, right now they're in phase. Okay, so if I turn on that one here, let's see. Then you can see the signal. This is a channel 2. This is a channel 1. So basically you can see Just a minute. No,
Chú có đọc email không?
không sao.
Không, thì lúc này nó kêu mình phải trả lời mấy cái câu gì ở trong cái làm review á. Rồi bây giờ chú muốn làm sao?
Thì tại muốn làm sao rồi. Đúng không kể.
Ok,
Ok.
dạ, cảm ơn.
So basically, you can see the fade, they will not in fade. Okay. So now if I turn it not here, and let's see. Okay. So you see the fade, they will be different. And they want to measure the different fade right here from that sideway and another sideway. We want to measure the fade. That means how much they ship it. How can we do? Who knows? Just tell me.
Oh, you want to measure the phase angle?
Yeah, that means you say two signal. One
Okay.
here.
Yeah. Measure from the top of one to the top of the other. And then
Ah.
count the divisions.
No, not yet.
Put the cursor there.
No, not yet. Before you want to do, can you tell me what the first thing we have to do?
I'll take one of the probably the reference one and count from one complete cycle, the number of divisions.
So if you right now you in this situation, just tell me what we have to do first to measure the phase.
Use the cursor.
Not yet.
Yeah.
Your guy already done it. Now you have to tell me. First thing, what we need to do.
Mr. Pham, you wanna have take your reference way, which is usually the input, and measure it for one complete cycle. See how many divisions you have.
We understand the way how they come up with. However, right now we're doing the left up until this point. Then you have to tell me next step, what we have to do.
Know which one's input, one's output.
And you understand one thing, okay? One complete cycle. Complete cycle,
One complete cycle is 360 degrees.
okay?
And you wanna take you wanna take those, that's why you want one complete cycle and and make 360 degrees and then count the squares and see how it works out. It was 8 squares for 360 degrees or 10 squares for 360 degrees.
You can do that way. Okay. Now, you understand a one cycle, T, equivalent 360 degrees. My question still, we're up to this point. Can you tell me what we do night.
Determine which one lags and which one leads.
No, we do nothing but leading, lagging for now.
Well,
We want to measure.
other than what Joe's saying, you gotta turn the cursor on, measure from peak to peak.
No, not completely right.
The correct steps, I understand.
Who
Right.
already done on that one? Tell me.
All right, Mr. Pham, it's almost 9 o'clock. You're gonna have to tell us.
Okay, now I telling you. First thing, I need to display only one cycle. I not display two,
One sine wave.
one sideway.
And the sine wave you're gonna display is gonna be the input, which is usually the reference.
That's only one, channel one.
Okay,
Okay, now you have to telling me complete one cycle. How many division for the time?
well, on the screen there, try to have only one sine wave on the screen.
That's what I want to see for one cycle of this signal. How many division?
Exactly.
Right now, you have four
Oh,
division.
Okay, yeah, so why don't you do this? Why don't you move the sine wave down so you can have equal amounts on the negative peak and the positive peak? In other
No,
words.
no, we don't do any negative, positive peak. I asking you
Mr.
about,
Pham, you're not listening to what I'm saying. I'm just trying to make it so we can utilize the X and Y axis and then go from left to right and count the number of divisions like Mike was saying.
Move the signal to the right so you can see a complete cycle starting at ground.
okay, now that one here, and we want to move it left or right, doesn't matter. I asking you for this signal here, one complete cycle, how many division?
1, 2, 3,
Four.
say 4.
1, 2, 3, 3.8.
Okay, well, you're there, we're here. We can't see it as sharp as you can, but it's close to 4.
Okay, let's see. 4. Okay,
Change
All
the
right.
time base.
so now I telling you here. Okay, so display channel 1 only. Okay, and adjust. Okay, signal to see how many time division.
How many time division for 360 degrees, right?
For one,
One complete cycle.
exactly. Complete cycle. Okay. Indeed. So for division. Okay. So that 4 division equivalent to 360 degrees. 4 division equal, okay, 360 degrees. Okay, so how many degree for one division?
90.
Okay, how many degree?
360 divided by 4,
Exactly.
and that'll equal 90.
Yeah. How many degree? Okay, for one division. That is 90 degree.
Oh. That's crazy.
Okay, so now you already know X division will be 90 degree. So now you display channel 2. Okay, so you can see between either way you want, the top of channel 1 and the top of channel 2. How many divisions? If you don't want to do it that way, you can using the cursor.
You say that again? The top of what?
The top of signal on channel 1 and the top of channel 2.
That's like, is that one or 1 point something or less than 1?
So you can using the
0.08?
cursor. Okay, you're using the cursor. You can measure either way. You can measure from this guy to the other guy here.
Right.
Okay. So basically, they're very close to 1. Right?
Yeah, it's like 0.8 or 9
Yeah.
or 1.
0.8 or 0.9.
Yeah.
So now one division equals 90 degrees. And you get 0.9 or 0.8. How many degrees? You take 90 times 0.8 or 0.9.
90 times 0.8 is 72.
Yes. So basically, you get the difference. A
90 times 0.8.
0.8
0.8 times 90.
division. Right. Then angle A 0.8 times 90 equal around 72, right?
Right.
Degree. Okay, so that's how come you can get the phase difference without using the formula. This is what they just showed you they wanted to measure. Okay. And in order to measure the phase angle, I try to repeat it. First thing, you display only one channel. And make sure you try to see how many times per division for one channel. That will be equal to 360 degrees. In this example, you say you get 4 channels, 4 division. You take 360 divide 4, that's telling you 1 time division equivalent 90 degrees. And now you want to see the difference right here, okay, between 2 signals. Then you can see how many divisions. In this example, you get 0.8 division. Then you take 0.8 times 90 degrees. And that given to you, phase angle will be 72 degrees. Okay, the last one. Which one will be leading? Channel 1 or channel 2?
Look like channel 2 is, channel 1 is leading and 2 is lagging.
Exactly. You say that at channel 1 here. They going up before the second one. So they will be leading. Leading 72 degrees. The next one, okay, they will be lagging. So either way, you say channel 1 leading, channel 2 90 degrees, 72 degrees, or channel 2 lagging, channel 1 by 72 degrees. So I hope we get through today. Later on, whenever you have to measure the voltage using the scope without rounded, then you have to using channel 1 minus channel 2. That is a point. A second one, if you want to measure the phase angle, then you have to following step by step in order to get the correct answer. Okay, so far, any question or any comments, anything else, just let me know. Next week, I will be trying with the semiconductor, but basically I just select a certain circuitry and you need to know, and I will be teach you. Not every circuit. We don't want to show you following step in left phone to do it. Try to understand what are you doing. Then I will be telling you, when you do everything, you enter the value. They say incorrect. That means something must be not right. How can we fix that problem? Okay. I don't think that still take a little longer time. For my job, I have to working with my camera to see how can I easy to move from one I want to display to the other without too much interruption. Okay, so you guys get any question or anything?
Thanks for everything, Mr. Pham. Good job.
The thing is, I want the people know what to do. Okay, and Okay, any question, anything I can answer to you.
Thank you, Mr. Pham.
I hope you can get something helping you to get the lab vote done quick.
Thank you.
You're welcome.
The way you show us today is big count. It's really clear. Thank you very much.
Yeah, you're welcome.
Kumi gonna show me on Wednesday how to do it.
Yep, on my
Yeah,
list.
for my understand, for my see, Kumi did a very good student.
Very good.
Yeah, she start before, fall 90, 2019, and be in the program on the time. And I saw the progress. She get much better. Okay. Only thing is, try with the left foot. When you know right away what you want to do, then do okay.
Thank
You can
you.
be a very good technician.
Thank you.
You're welcome. Okay.
All right.
So if no more questions, so good night, everyone.
Good night, Mr.
Thank you.
Pham.
Good night.
Tomorrow.
Good night.
Night.
Good
Good
night.
night.
everyone.
Good night. Don't let the bad boys bite.